Hello, this is Jenk Squad, and this is our teardown analysis video. We have chosen to analyze an automatic blood pressure cuff purchased from the local CVS pharmacy. This device allows users to measure their own blood pressure and pulse rate with a single push of a button. The cuff consists of a nylon outer layer with an adjustable Velcro strap to fit different arm sizes. Inside the outer layer is an inflatable sac that fills with air when the test is started. This sac is connected to the main device with a rubber tube and plastic connector that directs the air through the inlet for pressure sensing. The main device requires 4 AAA batteries fixed in series to operate. The housing is secured by 4 screws, one in each corner. Once removed, the front cover comes loose, exposing the display and circuit board. The device has an LCD display but no backlight. The user interface consists of 4 buttons and is easy to use. Blood pressure and pulse rate can be measured with only one touch of the central power button, and the memory and the plus button, which is a button that accesses the device's memory bank, which can hold up to 120 readings across 2 different users. Finally, the clock button allows for time and date adjustments. The display sits in a plastic housing and is attached to the circuit board by a flex. Plastic anchors secure the board in place. The circuit board will be explained in more detail later on in the video. Behind the screen, the pump motor is fixed to the housing by a plastic bracket and 2 screws. It is also insulated by bubble wrap to prevent any displacement if the device is moved. The silver portion of the motor houses the primary mechanical components. The white plastic portion contains a small rotor arm and rubber diaphragm, which work together to generate a positive air pressure directed out of the cuff. The entire motor pump is connected to the circuit board by wires, which power the motor, and tubing, which attaches to the pressure sensor on the back of the board. This tubing provides a network between the blood pressure cuff, pump motor, air valve, and the pressure sensor. When the user presses the start button, the motor turns on and the cuff inflates around the patient's arm. It inflates until the patient's pulse pressure can no longer be detected by the pressure sensor, this value being the systolic pressure. Then, the valve slowly releases air, and the pressure sensor can detect the diastolic pressure when pulse pressure becomes negligible. All this information is integrated by the microprocessor, and the heart rate and blood pressure are displayed on the screen. There is also a risk scale to indicate whether the patient has abnormally high or low blood pressure. This small rectangular silver component is the pressure valve. It is also connected to the board by wires so that the microprocessor can regulate the valve. The bottom of the board contains all the wire connections. Batteries provide the device power, and as you can see, the main positive and negative wires connect the spring battery leads to the board. The secondary wires branch from the board to provide power to the motor. A third set of 2 black wires span from the board to the valve, as explained before. Here, you can also see where the tubing connects to the pressure sensor. Now let's take a closer look at the pump mechanics. 3 long screws hold the plastic components together, as you can see. The first piece connects the pump to the inner tubing and directs the airflow. The second piece contains a rotor arm connected to the rubber diaphragm as mentioned earlier. A final plastic piece is secured to the metal housing with 2 screws. In the center is a plastic piece that connects the metal rod extending from the motor to the rotor arm. This allows the motor rod to turn and generate air pressure within the tubing. Finally, here's a larger view of the circuit board. On the front, the main component is a glob-top microprocessor which regulates most of the device's operations and tells the other components what to do. There are also collections of copper pads that form the button connections. On the back, there is a large electrolytic capacitor in the upper left corner. In the center is a crystal oscillator which helps the device keep a regular clock. The JRC semiconductor handles information processing as it is converted from pressure sensor readings to display values. This pressure sensor is on the right with a port that connects to the tubing. The remaining small components are resistors, capacitors, transducers, and other various electrical components. All of these work together with the mechanical parts of the device to provide accurate blood pressure readings. Thank you so much for listening to our video, and for a more detailed analysis, please visit our webpage, which we have a link up of at the end of the credit slides.